guys, so keep solving our physics GRE. So we start from 21 and hope we can go to 30. Okay, so 21 says a soap field with index reflection greater than errors. Okay, so you should understand there is a soap and this is N2. The index is N1. So basically N2 is larger than N1. And the optical film theory tells us that so if light pass in, then there will be a phase. Suppose this is zero phases, then this must be 180, 180. Because you from the speed of light, the large speed go to the small speed, then there will be a phase change. And vice versa, there is no phase change when you start from the lower speed to the larger speed. Okay, so the A said the top of so, and he said the bands of color observe lower parts, but area near the top appear black. So this is black. The top of film observed all the light incidents, none of it transmitted. So the first one is too strong. Also make no sense. The second, because he also all of the lights. Okay, so the second said the thickness of the top of parts of has become much less than the wavelength visible light. Basically, you can see the optical theory tell you that from this, if you want to have if the light and the refraction have two T1 equals to, T1 means the thickness equals to lambda, which means deconstructive. Because there is a phase 180 difference, and the 2T1 equals to lambda plus if there is a lambda difference, means that it's deconstructive. But if there is a lambda plus a half difference, so it means that a 0 plus a half difference, which this is constructive. Okay, so you said that the thickness of the top part of the soap film has become much less than the wavelength. This is maybe correct. This can be correct because this is too small. So your 2T1 are too small. So there's no way that 2T1 can equals to lambda or lambda over 4. Then so there's no constructive there's no constructive refraction. So you see all of it is black. The intensity is too low. So 2 is correct. There is a phase difference of all wavelengths reflected from the first surface of the soap film. Basically, this is what I said. There is a phase difference from here and here. So if this is 180, then the reflection is still 180, and out here still 180. So there is a phase difference, but there is no phase. So D said there is no phase change for any wavelength reflecting from a back surface is here. So there is no phase change here. Okay, so what we need to the answer should be 2, 3, 4. 2, 3, 4. So we should choose we should choose E. We should choose E. Okay. Okay, so 22 says a simple telescope. This is E. The tinsel pedestal consists of convex lens. Okay, so the O, this is the standard standard subject GRE. All you need to is know is the magnification is equals to the object of focus over the focus length of light. So that if the focus length of the object is 1 meters and the angular magnification of a telescope is 10. So you can tell the 10 equals to 1.0 divided by I. So I is what? I is 0.1. And then he said that what is the optical path length between object and I. So the answer is just FO plus FIE. So these two formula you need to remember. Okay. So these two tell you that D is equal to 0.1 plus 1, which is 1.1. 1.1. 1.1. So the answer is D. The answer is D. So 23, the Fermi temperature of copper is 80,000 K, and which will follow most nearly to the average speed. Okay, so this is called the Fermi energy. To solve it, it's trivial because the Fermi energy is, by definition, is just the Fermi temperature by definition is just KT equals to this. Okay, so basically you know K and you know T and you know M. So you know K, you know T, and you know M. So the rest of just direct computation, you can just solve V. So V is equal to 2KT over. Okay, so remember the he asked about conduction electron. So this M is the electron. Okay. So if you don't remember electron mass, then you can Google, not Google. You can go to the previous page. I think it's the first page. In the second or first page of subject GRE, there's a formula tell you that what is the proper number what you need to use. But I use 9.11. But usually you can just directly use 10 to the negative 30 and plug 2 times 23 times 80,000, and you can compute by yourself, which is, I guess, it's 10 to the 6. I only calculate the 10 to the power and check the first number, and neglect some 1 to 10 constant. So the answer is E. The answer is E. Okay, so 24. There is no basically this is chemical question because the argon is the noble gas. It's the noble element. So that means there's no the only the interaction term between them is the van der Waals bond, because which is not, this is not metallic, and there's no ionic. So the only answer is the E, van der Waals bonds. And 25, if it's an experiment located deep underground, the two types of cosmic rays most commonly reach the experiment apparatus are. If you follow the physics news, you will say people going to underground to find the neutrinos, right? So the answer is muon and neutrinos. And the reason is that in order to go into deep underground, the particle need to have the small size and they have the higher speed. So alpha particle and the neutron and the proton electron are somehow so too large, and the neutrino is very small. So what we will choose is muon and neutrino. So 25, if you are following the physics news, then you should know the answer is D. You should know the answer is D. Okay, so 26, the radioactive nucleus decay, which with the activity shown in the graph, the half-life. So half-life is what you need to ask. Answer is how much time it takes to let your population become half. Okay, so here is 3.10 to the 3.1, 10 to 3.2, 10 to 3.3, 10. So your starting point is this. So your initial population is 10 to the square root of 10. This. So this is, I can approximate this is like 3. So your starting point is like 3,000. As you see here. And so half of 3,000 is like 15,000 or 16,000. So probably this one. This is 1000. So this is 3.1. Okay, so all we need is calculate somehow this one. Actually, I don't know this one how to compute. Okay, but you know that it should be three. It should be okay. So let me somehow compute this. It tell you that it tell you some formula which you can use. So how about we calculate this one? 3.2, which is 1000 times 10 to the point 2. Okay, so because log 210 is 0.3, so suppose we take log. I select this is x, and I take log. I get 3.2 equals to log 10x, and what? Let me see. How I can compute? Let me see. So 1000 times okay. Let me see. How about we do this? So we can estimate a bound for this. Although we are not easy to get the answer, but we can still estimate the bound. So this is the 10 to the 3.2 power. So it must larger than 1000 times. This is 2, right? So it must larger than 2000. So that means this is 10.3.1, 3.2. So that means it should be in the middle. So it should be probably 7 to 10 minutes. So which one is the half life? You already get the answer. 7 minutes. 7 minutes. Well, we just need to estimate a lower bound of 10 to 3.2. Okay, so 27. Free multi electron and ask about the peak of the what's the width of the peak of in K. This is you don't have to do any calculation. Need to ask you about the uncertainty principle, because you have delta P x delta P is is close to h bar, and the delta P is h bar delta K. So delta x times delta K should be close to 1. So delta K should be 1 over delta x. So answer is B. Okay, so 28, the system known to be normalized state wave function. Ask about which one. This is YL. ML is a spherical harmonics. Basically some strange combination, some Legendre polynomial, which nobody cares. Okay, in this azimuthal orbital quantum number m equals 3. That means if you measure, you ask about what's the probability that you can get m equals to 3. Okay, so so you just check what's the component of m equals 3 and the probability proportional to amplitude square. So the amplitude for this y43 is 5 over square of 30. This is 1 over square root of 30. This is minus 2 over square root of 30. And which one has the m equals 3? These two, right? So we can square them. This is the answer. Okay, so the answer is E. Yeah, the answer is E. So this is just the quantum mechanics computation. Because all you need is, if you think what I did is too rod, then you can do the standard. You can use m equals 3's wave function, and do do the overlapping, and then you can see when you do the m equals 3 operators, then it will only non-vanish at least 2. Okay, then you can get a same answer because both are orthogonal. So only their square, only some of their squares are meaningful. Well, 29 asks about you have this attractive well, and then there's ask about bound states. Okay, so remember that when you have a bound state in the middle one, the wave function should be sine or cosine, and when you out of the when you're out of the well, then your total energy become negative. Then it's exponential decay. So the first one is not okay because when you're out of x1, x2, there's no exponential decay. So let me summarize. The first one is that in the well, you should be sine x, cosine x out of the well. You should be this one. So the first one is not okay because it goes to infinity. Okay, so the wave function cannot be normalized. So B looks okay, sine, cosine, and blah, blah, blah. And the C is not okay because this need to be continuous because this well is not infinity. So the wave function and their double prime need to be continuous. So C is not okay. D is impossible, right? In the middle one is something straight line. If you're solving a differential equation, it's hard to get a straight line, right? None of E because there should not be any oscillation out of the well. So this can be derived from Schrödinger equation. The answer should be B. Okay, number 30. I don't know if you're doing other old GRE exam and you already know the answer, but I would like to say that this is basically you need to remember that the Bohr model this is the standard model you need to remember. But you need to remember this 13.6 actually there were just proportional to the effective mass of the system. The effective mass of the system in a usually helium in a usually hydrogen model is the effective mass of electrons. Actually, it's electron times the proton, and the electron mass plus the proton. But the proton is the mass of proton is much larger than the mass of electrons. So this is closer to the mass of electrons. So, but in the positronian, positronian means that which there is a positron. So positron is the particle which is they have the same mass but of an electron but have the positive charge. Then if you plug this formula, you will see the effective mass is me over 2. So that means this 13.6 will become 6.8. So that means En in the positronian will be half the original hydrogen atoms. So basically, you should remember this. Okay, so then it's easy because E naught is this one. So positronian has E naught divided by 2, and also n equals to 2. So there is a 2 square here. So it's E naught over 8. Okay, so it's very happy that we already solved it. So there's no much question we face it. So be sure to subscribe to my channel. I hope to see you guys in the next video. So that's it.